Hello, welcome back to Blender Station LiveNoding. In this episode, I'm gonna take a look at these molecular nodes for Blender by Brady A Johnston. So it's basically a tool to use Blender and geometry nodes to import protein data. All right, so you can visualize it inside Blender and render it nicely. So you can take a look at the documentations. So it's utilizing Blender geometry nodes. So once you install the add-on, you can actually see some new nodes for geometry nodes. You're gonna go through the process of installations. There's a tutorial. I'm gonna try to cover this using Blender 3.1.2. So first of all, you download the code as a zip. Okay, so that's the first thing. And once you get the zip file, you unzip it, and inside of this folder there is a release and these molecular nodes with the versions. So this is the zip for the installations inside Blender. Okay, so I will delete everything, go to edit preferences. I'm gonna show you the add-on is already installed on my computer. You need to also install Atomium, so you need to click this once and it's gonna work. Okay, so you install as usual from molecular nodes, release, just use this zip. Okay, so if you install everything correctly, you will see there's a new panel for molecular nodes. All right, so there's a way here like to download from PDB, which is I think protein data bank or protein database, I don't know. This is not like you basically need to input 4-letter codes, and I believe it will allow you to load the protein data. So if we use this 1BNA, it's gonna try to import it from the internet. Now we have something which is just like a bunch of random points. Let me save this very quickly. So this is, I'm just gonna call it atom test. So we want to visualize this. It's currently just a dot, but with Blender 3.1.2 with cycles, you can already see these points as sphere. If you use geometry nodes, let me show you very quickly. Geometry nodes, create new. Normally, you're gonna do it like this, mesh to points. Once you do that, you can render using cycles. Just create a quick sunlight or point light. Okay, so that's basically the process. But here you can see, okay, it doesn't look quite nice yet. It doesn't. We have the data that goes into this collections, this folder. However, we haven't used anything. Okay, so if you Shift A, you can see there's this molecular nodes, and we have a bunch of new nodes for geometry nodes. So this is in relations to the protein database. We're gonna try to do something here. Okay, we start with the atomic properties. All right. So I'm actually selecting this guy with geometry nodes, so I can right away just use the geometry. So I delete this. So our geometry is just a bunch of points originally, right? And these nodes will handle everything, converting the mesh points into sphere, atomic, and then we can now colorize this with materials. So I'm gonna create a material, and then we're gonna try to stylize these nodes, these points. I believe this style color is the one we can use. So we need to specify the material and then the atomic. So there's a lot of data being passed around the nodes. I believe this one just connected there. So it's fairly intuitive, I believe. So I'm just gonna call this atom material. We want to see all the colors here for the carbon, oxygen, nitrogen. The output, so there's this output that we pass out into this guy. We just gonna name it color, and now we're gonna check the shader, the material for this, and use the attributes color, pass it into the base color. Okay, so it's not working as expected. Oh, okay. Maybe I haven't specified the properties. The properties we need to specify manually. Okay, cool. There you go. It takes a bit of steps, but once you've done it, you don't need to do this again and again. So, okay, we have one BNA here. So this is basically what it is. This is the most basic example. You can see this is not completely random. Okay, so it's not completely random. Like this is one BNA. What is one BNA? So if we, first of all, let's see. If you Google for PDB, you can actually go to this website and then take a look at the database. So it's a little bit geeky. You're probably not a scientist. What is one BNA? Is a structure of DNA, some kind of DNA strands. This is how it's get visualized using Blender cycles render. So it's still okay. It's looking indeed like a DNA. Maybe there's a few things like the connections that can be visualized better, but currently it's just a bunch of points, right? So it might be the add-on still work in progress, but still interesting. So like I said, it's not completely random, but you can sometimes find a like code that's kind of looking funny like this, like one lol. So you can say you put in one LOL and download. It's gonna fetch it from the internet, so you need internet. It's gonna download the data. So now you have new data, this bunch of points. You can see, you can start to see the structure. So if when it's downloading the molecular data protein database, it's gonna have these properties that's hidden, and there's this mesh. Okay, so the idea, of course, you are using geometry nodes and a bunch of nodes, molecular nodes, to get the result like this. So now okay, I will select this guy and select this guy, and then Command L, and gonna copy the modifier. Okay, first of all, gonna copy the modifier. So we can render this guy. Okay, so it's gonna get the material while the data is coming from different properties. Okay, here's the thing. This is the properties for this protein, but we want to customize it into this one lol. Okay, one lol is the new properties. So now this guy using the one BNA, this one is using one lol. Now it's gonna render properly. So the color by default, yellow is sulfur, red is oxygen, blue is nitrogen. Isn't it interesting? I mean, carbon is gray, and then hydrogen, I don't see any hydrogen. For my perspective as a 3D artist, and I like to just experiment with things, and I like this protein data because it's not completely random. Although you might look at it, okay, it's just like a bunch of points, right? It's nothing. It's not like it's atomic molecular protein data, but so it's not really random. But you probably think, okay, it's just a bunch of random points scattered with random color. So I'm gonna show you something funny that I've found. There is also this tool like animations. I haven't looked at it properly, but there is this points in volume, for example. If we are using these points in volume, you can see it's gonna generate random volume. Okay, let's say, yeah, you have a bunch of random points in this volume. This is when it gets interesting because this thing will render as well, right? So it's this one is random. It comes with the molecular nodes, and then you can also use the noise. There is a 3D noise, and there's the normal that you can pass. You can do like some fancy geometry nodes set up like this. 3D noise goes into the offset, and you can basically play around with this. So you can use the position, and you can offset the position, and yeah, you can animate this guy. Oh, okay, there's this animation as well, so you don't need this. Just use the frame time, goes into this guy. It's gonna animate. It's kind of cute. It's a protein data, so it's kind of animating. So in a way, you can perhaps do the same thing with the with this atom. Yeah, you can wiggle it. There must be another way to do this, but yeah, there's a bunch of nodes here. If you have, I think some protein data actually have like an animations. It has like multiple frames data that you can observe. That's where you probably want to use MOL animate. Anyway, so let's get back to this business over here. There's a bunch of nodes that's kind of interesting for me, like fine bonds. Okay, fine bonds is cool. We have this atom that's kind of close together. With the fine bonds, you can output a stick. Look at this. This is how atom kind of, I think, connected together, and if it's close or far, it's gonna try to draw the connections. Imagine if you kind of look at the data like maybe like a Twitter data or Facebook data, and find the connection between you and other users. It's probably gonna look like this atomic. So the atom, we have the atom, and we can create the stick. There's also this bond curves. I don't know what it is. I think it's just another representations of the curve. So we can output the stick and the ball and the balls together. And where's the stick? Oh, the stick is there, just sometimes a little bit hidden. I wish there's a quick way to just control the radius. There's a scale radius. I tried using this, but I'm not exactly sure what's going on. If I plug this, it seems to be disappearing. Yeah, probably this shouldn't be attached after the stick. No, yeah, we need to ask Brady about it. But there's another note that's really interesting, is this style surface. Okay, I tried this. If we just plug the atom and get the surface, and then pipe the attributes color, we don't get anything from the color. We get some kind of surface, and we can have like a different level of surface. So it's like creating a surface from the points. Get the material. Okay, cool. Yeah, we can actually get some kind of visual here, like the color from the atom. So we have this surface that probably we can give like a different material, so we can see the surface and the material itself. Let's say I make like transparent material. I'm gonna set the material here. I'm gonna use transparent material. With the transparent one, I will play around with alpha, and yeah, it should be transparent. Now we can join our original geometry and the surface. Okay, pretty cool, right? This is the transparent material. Yeah. Okay, so if we are doing like random things, because this is geometry nodes and it's already kind of turning this into a mesh that we can render, you can actually play around and just use mirror, for example. And you can perhaps like just print it out or something, or just playing around with these ideas, because we have like, it's random, but like I said, it's not really random, it's basically protein data. So you can take a look. Maybe there's like a gallery or something that we can pick. So this one, for example, 7KKH. 7KKH. You can download another protein data. Okay, another random looking points. Select this, Command L, copy modifier. We should get result right away. I found this cool because you can really just render it whatever you like. For example, I'm using a random protein data the other day, and yeah, I render the outside surface as glass and keeping some of the inside. I mean, but I'm also using random flow just to generate these weird stripes. But yeah, I think the results quite interesting looking. It could be like a design for some kind of futuristic sci-fi vehicles or something. But yeah, I'm using real protein data here, and yeah, this is probably for something else in the future completely. But yeah, since I'm not like a scientist, but it's still kind of interesting to be able to visualize the data. So yeah, again, the add-on, this is my first time using it. Molecular Nodes by Brady A Johnston. It's based on a Python Atomium. So I think if you know Python, you can use this what is it called, this module, and you can fetch the data like protein data and then try to visualize it differently, or just get the data, etc, etc. The add-on is doing the same thing, just so that you can visualize it inside Blender. So this is the protein. The one lol is funny name for this protein data. I don't know what else we can have. We can try. Some of them might actually not do anything. You can probably like download protein data for coronavirus or something, and you can visualize it over here. And just the way it's kind of animating, or how it's kind of connected together. I don't know. So I'm downloading another protein data. It should come into Blender as just bunch of points with properties. This one seems pretty huge. Okay. Yeah. It's looking a little bit like that. It's pretty cool. And select this since we already have the geometry node set up. Now so we have a result instantly. Okay, by the way, the material, the way I like to store the material is like this. We have the atom material and we have the transparent glass material. This is just a transparent material, so I just like to replace it with glass BSDF. So we can visualize this a little bit nicer. Why is it red? I don't know why it's red. Maybe I will disconnect this and just look at the, oh yeah, the original protein data is just mostly red because I haven't plugged the correct one. This one is 7VOT. So I'm gonna use 7VOT. Now it's correct. Okay, this guy, one lol. This guy. This one is 7KKH properties, so now it's correct. So again, this is how we visualize the data. Again, carbon gray, oxygen red, nitrogen blue, sulfur yellow. It's pretty cool. It's almost like the Olympic. And we can visualize it like this. If it's not beautiful enough, of course you can add a sky texture. Now it's starting to look kind of nice. Just a basic sky skylight. You can use HDR environment as well. This is using Nishita. You can use Hosex or Pritham, whatever you like. Just the basic lighting for you to play around. But I really like this one. It's looking like a little bit like snail, kind of attached together, twin snail. Yeah, you can turn this into anything. But so that's basically what molecular nodes is. I believe there might be more, a lot more from the developer. Maybe there's a tutorial from Brady himself. You can buy him a coffee here, donations. So yeah, but that's a really cool nodes for geometry nodes, allowing you to look at atomic data, protein data, and that you can study. I don't know if you want to study this, but you know, you can kind of see the structure of this protein, and this is something that might be inside your body or inside the different animals. I'm gonna turn on the noise as well. So yeah, so again, so in the latest Blender you can render curve and points, and then each point can be rendered as sphere. That's why it can look beautiful like this. And then you can use the style, and I'm gonna plug that in. Now we have the glass outside of the protein. All right, so hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.